Hi everyone, this is a short video about the rules and properties for exponents and exponential expressions. So one of the things that we're going to go through all of the rules that we've talked about in class. I'm not going to go through the detailed reasons why the rules are what they are. They should be in your notes. This is just a quick summary of what the rules are. So what we found in class is that if I have two exponential expressions, and they have the same base, then when I multiply them together, I can just add their powers. This is called the product rule, right? Because we are doing multiplication. So if they have the same base, I can multiply them together and just add their powers. Notice that the base still stays the same, right? The base was x, the base was x, the base is still x. So when we do the same, have the same situation when we have a numerical base, like 3 to the second power times 3 to the fourth power, same base. And so what that means is when we do the multiplication, we keep the base and we add the powers. So this is 3 to the sixth power, all right? Likewise, if the base is a negative number, like negative 2 to the fourth power times negative 2 to the seventh power, this is the base right here. And so that base doesn't change. What we are going to do is add the powers, and we get negative 2 to the 11th power. More often than not, I'll see something like 4 to the 11th power, meaning that the person multiplied negative 2 times negative 2. That is not what we want you to do. This is not the way it works. Again, remember, this is basically doing negative 2 4 times, then negative 2 7 more times, and altogether I have negative 2 11 times. Now, when we talk about, sometimes we need to do division with exponential expressions. So if I have x to the seventh divided by x to the third, what we learned in class was that I can do subtraction with the powers, and I would get x to the fourth power. This was called the quotient rule. All right? Because I'm doing division, this is why it's called the quotient rule. Same thing with in terms of numbers. If I have negative 8 to the sixth power divided by negative 8 to the fourth power, the bases, since the bases are the same, I do subtraction with the powers. So this is, the base is negative 8, I do 6 minus 4, I get negative 8 to the second power. Now, of course, you can do negative 8 to the second power and get something like positive 64. You can do that. But the main purpose, or the main point here, is that if they have the same base, I can do subtraction with the power, and the base stays the same, right? If the base is negative 8, it ends up being negative 8. Another property for exponential expressions that we looked at was the zero power property, or the zero power rule. Actually, I should say rule here. Meaning that if I have anything raised to the zero power, it's equal to 1. Even if it's negative 3 to the zero power, it's equal to 1. Or it's some massive number, like 10 million to the zero power. It's equal to 1. Okay? And then I can do stuff with this. For example, I can say like negative 5 times x to the zero power. Well, that's really negative 5 times 1. So that's negative 5, right? X to the zero power is equal to 1. So anything raised to the zero power is 1, but you do need to be careful if there are other things being multiplied or added to something to the zero power. But the thing that is to the zero power is equal to 1. Sometimes when we have exponential expressions, we might have something like this. Oops. Yeah, make sure this is ready to go. X to the third divided by x to the 7th. Now, if I do the quotient rule, because this is division, and they have the same base, this is what I could do. X 3 minus 7 power, which would be x to the negative 4 power. But we want to know what x to the negative 4 power really means. And sometimes we can look at it in terms of the number of factors that we're dealing with here. And we can make this connection that this will cancel out, this will cancel out, and this will cancel out, leaving a 1 up here in the numerator, and leaving 4 x's, or x to the 4th, in the denominator. This is the connection. X to the negative 4th power is the same thing as 1 over x to the 4th. So anything to the negative, to a negative power, let me just change this here. I want to use something a little bit different here. Anything raised to a negative power, so a base raised to a negative power, we use the reciprocal. And we change the sign. Think of this as like this, b to the negative x over 1, and we're flipping it over. So if I have 4 to the negative 2 power, think of that as 4 to the negative 2 over 1, and I flip it over and I put the 1 in the numerator, I put the base with the power in the denominator, and I change that power to positive. Okay? So if I have 12x to the negative 7th y to the 3rd, I'm going to, remember, if we keep this as over 1, and over 1, 12 stays in the numerator, y to the 3rd stays up in the numerator, x to the 7th goes down to the denominator, because that negative power says to flip it down here, and then we change the power to positive. All right? So negative powers tell us that we need to flip or use a reciprocal. Likewise, if I have something like 1 over x to the negative 3 power, that negative 3 is telling me that it needs to flip up to the numerator. So it becomes x to the positive 3. And this is over 1, so you could just leave it as x to the 3rd. So 1 over x to the negative 3 power is the same thing as x to the 3rd. It flips up to the numerator. So that negative power tells you to change location. That's what it's really telling you to do, to change location. That's the end of this short video about the product, quotient, zero power, and negative power rules for exponents.